This video covers organic acids, esters, reactions producing esters called esterification reactions, as well as a brief review of all the other organic reactions that we have covered so far. Organic acids are in fact acids. They are located here in the table that we've been looking at for the last 2 or 3 videos. All organic acids have a carbon, and at the end of that carbon there is a double bond oxygen and an OH. So, the R right here could be a chain of carbons, but at the end of that chain there's going to be this thing. This thing is called a carboxyl group, the C with an O and an OH, and that's called a carboxyl. And that carboxyl is what they call an ionizable hydrogen. It's got a hydrogen that when you put this substance into water, that hydrogen comes off to some extent. Now these are weak acids, which means they don't ionize completely. Only a small percentage of the molecules do this, but you always get some H plus ions, and it's always this H right here that comes off. So you could have a molecule like this right here. Now this right here it has the COOH, at the end. It only has one carbon, so its name, instead of propanoic acid, since it has one carbon, is going to be called methanoic acid. And while it has this other H over here, that one is not affected. The H that comes off is the one that's covalently bonded to the oxygen right there. And that's the ionizable hydrogen. So if you look at the next example right below this one on this molecule here, these hydrogens don't come off. But this one here is the ionizable hydrogen. And when it comes off as a hydronium ion, written as H plus or H3O plus, because it will stick to water molecules, which means it has a pH of less than 7, because there'll be more hydroniums than hydroxides. That's what makes it an acidic solution. Solutions of these acids will change colors and indicators. They will react with metals. So an acidic solution will, react with metals that are active. And finally, because of the presence of the ions, it will be an electrolyte, and it will conduct electricity because of the mobile ions in the solution. Now, nomenclature. Very, very simple. If it's got one carbon, basically it's methane. You take the E off and you write oic acid at the end. If it has 2 carbons like this one, it's now ethane, but you take the E off and then you put oic at the end and write the word acid. Again, only one hydrogen really comes off or ionizes, and that's the one that's on the carboxyl group. The next one down here has 5 carbons, so it would be pentane. But again, you take off the E and put an oic at the end and write the word acid on it. Now, all of these acids, one of them that's kind of important is the second one, this one, ethanoic acid, only because it's so common. Ethanoic acid is also known as acetic acid, and its even more common name is vinegar. And when this ionizes, you get the acetate ion. Now, I'm not going to put the other chart on there, but basically, this has 2 carbons and 1, 2, 3. If you get rid of this one H right here, what you end up with is 2 carbons, 3 hydrogens, and 2 oxygens with a charge of negative. And this is the acetate ion, which you can see in the polyatomic table, which they drew 2 different ways. One way was to show the Ku at the end, basically. So that's why that's there. And this is vinegar. By the way, vinegar is basically, acidically, about a 5% solution, which means it's 95% water when you buy vinegar. The other 5% is vinegar, and if you're buying like balsamic vinegar, there's some other compounds in there that make it, brownish vinegar or red vinegar if it's wine vinegar, something like that. All right, so that's naming acids. Let's talk about the next row, which is esters. Now, let's talk about this in the table here. See, it says methylpropanoate. All right. And what you want to see before we get over to the next page is this thing right here. This looks like the Ku without the H on it. Let's see what happens here. All right, so an ester basically is formed by what's called an esterification reaction. Now, esters have this in the middle. They have a double bond O and an O like that, and it's connected C. It'll be in the middle, and then there'll be 2 chains of carbon, one going this way and one going that way, and they're formed by a reaction that involves an alcohol and an organic acid. They tend to have fragrances. They tend to smell. So there's one called vanilla, and there's another one called banana something. It smells like bananas. They literally smell like things that are found in fruits and stuff. Matter of fact, when I was a kid, we used to have these little scratch-off things that we used to get. And you'd scratch them, it would smell like strawberries or bananas. I don't know if they still sell them, but basically when you scratch and you smell it, oh, it smells like bananas. It's an ester. All right, esters are produced by lots of fruiting plants, and they actually give the fruits their specific smells. They're also found in flowers. They're used in perfumes. So esters are very fragrant compounds. Okay, they have a strong smell. Now, in esterification, the reaction involves this, and the nomenclature of these guys is kind of annoying. So pay close attention. See this right here? Okay, it will always involve an alcohol and an organic acid. So this is methanol reacting with two carbons, ethanoic acid. Now I put the carboxyl group over here. Remember, these are three-dimensional things. So what I just did was I set them so you could see how they would line, how a chemical reaction would occur. And what happens is a dehydration reaction. What that means is you're going to remove water. So what happens is the OH from one of these guys comes off and the H from the other. And when that happens, these two guys combine, the AOH and the H, and they make the water, which is one of the two products that you're going to make. The other product is the ester. The ester will be, I'm going to draw it now. It's going to be the HH-C. Okay, so this thing is this thing right here with the one oxygen still there. Now that oxygen is coming from over here in this particular case. Now, remember, oxygen generally makes two bonds, right? So carbons tend to make four bonds, hydrogen's one, the oxygen is going to make two bonds, and so it will be still connected to this. So what I'm doing now is I started by drawing this molecule over here, right? And now I'm going to draw this molecule here, and the thing that's going to connect the two of them is an oxygen. Now, I didn't touch this oxygen right here, so the double bond oxygen is still there, and I've got the carbon here with the three H's. Now watch the naming of these guys. It's got two things. There's a methyl and an ethyl, right? So what they do is the one that has the extra oxygen on it gets the O8. So this is going to be called methyl ethanoate. Now just to make sure you understand how this works, I'm going to do a little erasing here. If I were to take this H, and if this had been, let's say, 3 carbons long, this would be propyl ethanoate. The thing with the 2 carbon thing gets the OH. So this is ethanoate, and now this is a propyl. If it had 4 carbons, it would be a butyl ethanoate. So the thing that doesn't have the extra oxygen just gets the YL. All right, and it doesn't have to be drawn this way. It can be drawn backwards. Remember, the one with the double bond oxygen, that gets the OH. So let's do another one of these. So this one right here, we have the alcohols right here. So this is ethanol, and this is methanoic acid, because it's an acid with a Q on it, right? And we're going to take the water out, and so this is going to come off of here, and this is going to come off of here, and now we're connected. So what we'll have is a 2 carbon thingy with an oxygen connected to a 1 carbon thingy with the double bond O on it and the H, and I'm going to put all the other H's in like this. And what this right here will be the ethyl. So this will be the ethyl over here, and because this has the extra O on there, that's going to become the methanoate. So this is going to be called ethyl methanoate. Now, ethyl methanoate, okay, what you can recognize is this. I always remember this extra O here. That's the one that's got the extra O on it, because it's got the O in the name. Some people just like to remember that the part that came from the acid gets the OH. So the methanoic becomes the methanoate. So this has, right, so this is the oic becomes the O8. It's up to you how you want to remember it, all right? Esters have smells. They have essentially, in the middle of them, they have a C and an O, and another O and a C. In the middle, one of the O's is double bonded to the carbon that was originally from the organic acid. All right, so those are esters, and they have fragrances. That's what you need to know. All right, here we go. So far you've learned 4 different reactions. You've learned addition, substitution, etherification, esterification. So I put one example on each of these, just to do a quick review, all right? So an addition reaction involves usually a halogen, but it could also involve a hydrogen, actually. And in an addition reaction, what happens? We break the double bond, and so in this particular case, we have carbon with a single bond as a product, and the 2 Cl's will be on the carbons that were adjacent to where the double bond was originally, and we would end up with 1,2 dichloroethane. only one product here. If this was hydrogen right here, right, reacting, you would end up with the two hydrogens on here, and it would go from being ethene to ethane. That's called a hydrogenation reaction, which is a type of addition reaction in which you had hydrogen. By the way, margarine is hydrogenated vegetable oil. So when you get margarine, they take like corn oil and they basically add the hydrogens, break the double bonds, and it turns from a liquid to a saturated compound, which is solid. That's called hydrogenation. And you'll see it in the back of labels that say hydrogenated vegetable oil. They actually did an addition reaction to make it. In substitution, what happens is the hydrogen gets kicked out. So you would end up with a saturated molecule again. All right, and again, I'm just doing a quick review. If you don't want to watch this, you don't have to if you feel comfortable, but I'm just figured it was worth it. And one of the bromines will kick out a hydrogen. Maybe the other hydrogens are still there. And because the hydrogen gets kicked out, you get two products, and one of them is like HBr. Etherification and esterification are both dehydration reactions. So in both cases, you're producing water as a product. So if this is methanol, and the second thing here is ethanol, and so you have two primary alcohols, and so you end up with a product which has a C with three H's around it, like so, and oxygen connecting it, and on the other side, two other carbons with hydrogens around it, like so. And what you get is methyl ethyl ether. And then finally, what we just did now, which is esterification, and in the esterification reaction, again, the product is water. You take out a hydrogen, you take out an OH, and I just miswrote this whole thing. So I'm going to put a double bond oxygen on this thing and do a little erasing to make this work. We'll make this a double bond oxygen here. Draw. Okay, that looks better. So we have propanol and methanoic acid, and so when you combine those, you're going to get propyl, 3 carbons, oxygen, and then 1 carbon with the double bond oxygen. And because this is methanoic acid, and this is propanol, you are going to get propyl methanoate. And now I'll stick all the extra hydrogens on there as dashes to make it go fast. That's it. Those are the 4 reactions you've learned so far.